Okay, so continuing chapter 5. What we do right here for a minute isn't going to look that like proofs that much, okay? We will pick proofs back up, but we need to go over a few more identities and kind of talk about a few more things. By the way, the hole punches are like in really bad spots on this. So I think you have a hole punch right here where it says even, so why don't you write that in? And then there's another hole punch down here when it says even. So go ahead and write that in your notes. And one thing I'd like to discuss is this concept of even and odd functions. Now, you guys already know about even and odd numbers, but a function can be even, or it could be odd, or it could be neither. All right. So what the rule basically says is that if you plug in a negative number, like a negative x, and it goes away, like the result is not negative, it just, plugging in a negative is the exact same thing as plugging in a positive. This is called an even function. Okay? So think about squaring numbers. Okay? Whether you square a positive 2 or you square a negative 2. Now notice the parentheses. Both of these give you the same result, which is 4, right? Plugging in a negative does not change a squared. All right? That's an example of an even function. Okay. However, sometimes when you plug in negative numbers, it causes the result to be negative. That is called an odd function. Okay, so think about if I change that squared to cubed. Okay, what's 2 cubed? 2 times 2 times 2. Okay, it's that we got to get back into the swing of things. 2 times 2 times 2, that's 8. Okay, but what is negative 2 cubed? So think about this. A negative times a negative is a positive times another negative is a negative 8. So do you see where I'm going with this? Sometimes plugging in a negative doesn't really change anything. It kind of just goes away. Sometimes plugging in a negative causes the result to be negative. So that's the rule. Let me give you some examples that have nothing to do with trig, and then we'll relate it back to trig. So here's some examples of some even functions. Okay, some of you have been like, I love algebra 2, I hate pre-cal. Well, here's some good algebra 2 stuff. Does anybody remember what this function looks like? X squared. What is the parent function? You can give me a word or you can show me your arms. Yep, a parabola, just like that. Okay, 1 over x squared, you probably don't remember. It looks something like this. There's like a vertical asymptote. It kind of looks like a big wave or like a splash. Okay, now look at these two, and I only have 2 to go off of. I could have given you more examples, but they both have some symmetry right through the middle. Okay, do you see that? These are symmetrical across the y-axis. Which should kind of go with the whole plugging in a negative doesn't matter, because it's like looking in a mirror. Whether you go right or you go left, you get the same result. Plugging in a negative x value, which would be the left part, doesn't change the graph. Okay, so let's look at some odd functions. So y equals x. What shape does that make? Yep, a line with like a slope of 1. Okay, cubed looks like something like this. Cube root, you may not, this one's a little bit harder to remember. It kind of looks a lot like the cubed, but it's on its side. And then 1 over x looks like this. So I know you don't remember all these parent functions. It's been a long time since you've thought about this. And we're going to review all this next semester. But I wanted to kind of at least put it in your brain a little bit. Now, do these have the same thing where they're symmetrical across the y-axis?
No.
No. Do they have any kind of symmetry at all?
Well, Opposite, kind of.
So are they symmetrical across the x-axis? Like if I kind of put in an x and a y-axis here. If I flip it down, what if I did both?
Yeah.
What if I flipped it across and down? Okay, that would work, right? Let's see if it works on this one. If I flipped it over and then flipped it down, it would kind of repeat itself, right? It would overlap. Same thing happens right here. Same thing happens here. Now there's another way to explain this, and that is there's a rotational symmetry. It's a rotation. Okay, and rotate, you know, means like turning a knob. You rotate it how many degrees? So this is something we're more familiar with. How many quadrants have we moved this thing? If we think about 2 quadrants, how many degrees is in each quadrant?
Rotate it like 180 degrees?
Yeah. So we rotate it 2 quadrants, which would be 180 degrees. So that's going to be true for all odd functions. Okay, and so this is a more algebraic way of looking at this. So what I want to do now is think about how this relates to our trig values. Okay, so let's just think about sine and cosine. Do you remember the difference between the two when we graphed?
Where they start?
Where they started. So which one started up at the high point?
Cosine.
Cosine. So let me graph cosine. It looks something like this. Okay, and let me go ahead and put in an x and a y. Okay, so it started up at the top, right? Do you see how there's some symmetry across the y-axis for cosine? Do you see that symmetry?
Yes.
Okay, what this tells us is that cosine is an even function. All right, now if cosine is even, which one is really closely related to cosine? What's cosine's reciprocal? Secant. Okay, now I'm not going to go ahead and into graphing this one, but if cosine is even, then its reciprocal also has to be even. Okay, I want you to notice something up here. See how x squared and 1 over x squared, one was even and the other one was even? Okay, look at x and 1 over x. They both fall into the same category. So if you take the reciprocal of a function, it should give you the same result. Okay, so these are 2 even ones, and there may be more. Let's see. So if cosine is even, then you may be thinking something's implied, and maybe because I'm graphing this under odd, but let's go ahead and graph sine. So remember, the only big difference between these two was they both did up and down, up and down, up and down. But sine started in the middle, right? Cosine started at a peak. Look at sine. Do you see that symmetry, rotational 180 degrees? Do you see how if I took this little loop right here and I rotated it 180 degrees,
Yep.
it would overlap? Or if you reflected across y and reflected across x.
So rotational symmetry.
Rotational symmetry. And if sine is odd, then what else is odd? Cosecant. So the big question now is, where does tangent fall into it? And logic would imply that wherever tangent falls, cotangent would fall as well.
See what the little one has to do with that. Yeah.
So what does tangent look like? I don't want to give anybody any hints, so I'm going to draw it over here, and then we'll decide, okay? So tangent looks like this. It actually looks a lot like cubic, except remember there are asymptotes. So which one do you think this falls into, even or odd? Odd. And so is cotangent. It's not one of each. It's actually both tangent and cotangent are both odd. And there's other ways we could have categorized them. Now, in the end, if you kind of look down at the bottom, you might have seen this down here. It goes ahead and tells you The only two evens are cosine and secant. Okay? And here's why all of this matters. Okay? It really boils down to something actually pretty simple. Sine of negative 70. Since sine is an odd function, sine of negative 70 is the same as negative sine of 70 degrees. In other words, that negative, you can kind of pull it out to the front. That's it. That's what we're using this for. So it's actually pretty easy. I just built it up because I really wanted you to understand why. So secant, and let's go ahead and write in here odd or even. So is secant odd or even?
It's going to be...
It's even, which means that the negative completely goes away. And if it's throwing you off, by the way, that I'm not putting parentheses, I apologize. We could or we don't have to, but where did the negative go? It totally went away, because that's what happens with even functions.
So how do you determine if it's even?
Here's what they are. The only two evens are cosine and secant. All the rest of them are odds.
And we just need to memorize that.
I have good news, but I'm going to wait till the end of class to tell you.
Is there a little algorithm?
Well, the only two evens are cosine and secant. That would be a pretty easy way to remember. But I have even better news for you, but you're going to have to wait for it. Okay, tangent. Is it even or odd? Odd. So does that mean the negative goes to the front or goes away? The front. So here's some problems that are pretty easy if you know which ones are even and which ones are odd. Okay?
So is that considered a positive expression or a positive argument?
Yes, so the whole positive argument thing means the thing inside the parentheses is now positive. Okay, so you're taking the negative, which is inside the parentheses, and for odd functions, you're moving it out to the front, and for even functions, it goes away completely. And the reason that is because of what we kind of did earlier.
And so those are the answers to those questions.
That's the answer. Because it doesn't say evaluate them, it just says to rewrite them. Now, why are we having to practice this? There is something that this could be used for, but right now we're just rewriting it. Okay, and you're going to have questions on your quiz where this is all you have to do, so it's pretty nice. Okay, so that's even and odd functions. Okay, now I want to talk about cofunctions. All right, so the co in cofunction stands for complement. I think I misspelled that.
I don't know how to spell very well.
That's how it's...
No, it isn't.
It's not.
Okay, and it's not a bad thing that I did that. I was like thinking I misspelled it. It's not in my notes in front of me. It's spelled like that because this is not a compliment that you give somebody. This is a complement as in complementary angles. Do you guys remember complementary angles
Sure.
from geometry? Okay, how many degrees is that? It's a right.
90.
It's 90. So if this is 40, then what's this down here?
60.
Or 50, because they got to add up to 90. That's what complementary. Do y'all remember the other word besides complementary?
Supplementary.
Supplementary. Okay, so this is that complement. That's why I misspelled it, and that's just
You
me.
can add a line to the C and make it a 90.
Yeah,
That's what mine.
this is where it's like the co. You just go like that.
Supplementary, you can draw 180.
Yeah, and we won't do anything with supplementary, so it's just co. So here's where I'm going with that. What's the complement of 36?
Oh, 30, 90.
You would do 90 minus 36. You can do this without a calculator.
C4.
So something 4. 64?
34.
54.
54. Come on.
Whoops, not 540. 54, and we'll put a degree sign there for good measure. Now, if this is in radians, we're not going to use 90, right? We're going to have to use pi over 2, and we'll practice that in a minute. So this is going to blow some of your minds. Are you prepared? The cosine of an angle equals the sine of the complement. It took us all this time for me to explain to you why it's called cosine. It's called cosine because if sine of 36 is something, and we can't do that without our calculator, then that is equal to cosine of 54. We're not talking reciprocal here. Did I let you in on the secret at the beginning of class?
No. I'm talking about the beginning of like this whole shenanigans.
Well, now you know. Okay, so what would sine of 20 degrees be? It would be cosine of 70 degrees. Okay, you can check it on your calculator. So I'm going to give you a minute to get your calculators out. And if you just have your phone, then you can actually do this on your phone. If you turn it sideways, it gives you the bigger calculator. And you can plug both of these in. Now you should be in degrees mode. In your phone, I don't know if you can change between the two, but it'll still give you the same. Actually, if you're in radians mode, it won't give you the same. Some phones may change between radians and degrees. Some phones may only be radians. Did it work? Okay.
Hey, Charles. No, Charles. Radian degrees right here in the corner. Doesn't. If I press sine.
I think you have to do the angle and then press sine.
You want it in radian or degrees?
Well, we're in degrees, so you would want to be in degrees. But I think if you're in radians, it won't give you the right answer, but it'll at least have the same decimal for each. Okay, so that's that. So we talked about sine and cosine. So what is the co-function of tangent? Put a co in front of it. Cotangent. Okay? Or COT. Okay? Secant. This is secant spelled out. We haven't, we normally see these abbreviated. What is the co-function of secant? Cosecant. CSC.
Same thing where they're 90-degree angles or whatever?
Yes. All right, now all the cofunction identities are listed here, and then we're going to practice it. So notice what we have here. Sine of theta equals cosine of 90 minus theta, or if we're in radians, pi over 2 minus x. Okay, and then it's the other way around as well. Okay. I do want to mention, by the way, let's draw the trig hexagon out here real quick. This is just good practice since we've been off of this for a while. There's not a whole lot of room. You can just draw it wherever you want. Do you pick out some cofunctions? Sine and cosine. How would you say they are related to each other on the hexagon? Sine and cosine, they are next to each other. Yeah? Tangent and cotangent. Secant and cosecant. Maybe say horizontal. Horizontal would imply left to right. So that's another way the trig hexagon can help you with cofunctions. Okay, so here's how we're going to do this. First of all, you got to look at what they give you, and you got to say, okay, what's the cofunction of cosecant? You either got to add the co, or you got to take the co away. In this case, take it away. So what should I write out here? Secant, so SEC. And then you got to take the complement of the angle. Okay, so that would be 90 minus 35. 55. And those two things are the same. Okay, what about tangent of 15 degrees? We're just using cofunctions. cotangent, and you got to do 90 minus 15, 75 degrees. That's it. Now, there are other ways we could take this with stuff we've already learned. This is just doing cofunctions right here.
So this one's going to be cotangent 5 pi over 7.
So now this one's going to be, so what you're doing is pi minus, which I know is what most people do. So let's not try to shortcut this just yet. Let's do pi over 2, right? Because it's 90 minus or pi over 2 minus 2 pi over 7. All right. Those are two fractions, and if I want to subtract them, I can't do that until I have a common denominator.
14.
So 14. So let's change the denominator to be 14, and let's decide what the numerator. So in the first fraction, I multiplied the bottom by how much?
You get 7 or 5.
7. So I'm going to put a 7 right there.
On the bottom, you get 4. Or on
I'm
top,
multiplied by 2, so I got to multiply the top by 2. 2 times 2 is 4.
You get 5 over 14.
Not quite. What's 7 apples minus 4 apples? 3 apples. It's just pi instead of apples. So it is a little bit of fraction work on these. The time it takes you to try to do this in your head, you could already have this done if you just write it out. You just have to remember to get common denominators. Now, I want you to scratch out this 8, by the way, because that's not a very good problem. I want you to scratch out that 8.
Would we have to simplify like 1.5 pi over 7?
I'm not going to give you that.
Okay.
Okay, so first of all, what would be the cofunction to sine? Cosine. And did everybody hear? We crossed off the 8. I messed up. It wasn't really a good problem. Because these angles have to be smaller than 90. Otherwise, we start getting negatives and all that stuff. I'm not saying that kind of stuff can't happen, but we're not going to do it. Okay, so now I have pi over 2 minus pi over 9. What's going to be the common denominator? 18. So we change both denominators to 18, and we say, oh, I multiplied the 2 by a 9. So multiply the top by a 9 in the first part. Here I multiplied the 9 by 2. 9 pi minus 2 pi, that's 7 pi. And so that's what goes right there. So the fractions, that's the hardest part of today's lesson. And not that bad. Say that again?
How do you get, like, for example, 6 hours of how do you get from sine or cosine?
They're cofunctions. Just think about it, sine and cosine. But they're all right up here. Right? So if you just look up sine and go, oh, its cofunction is cosine.